Good morning and welcome to Spaceport Tucson. My name is Matteo Jenna. We're here to watch a launch of one of our Stratollites. These launches are always exciting for us, so we're super happy we can share that with you today. I want to introduce you to Ryan Hartman. Welcome, Ryan.
Good morning.
Morning. So Ryan is the CEO for Worldview. So for people who are not familiar with Worldview, Ryan, how about you tell them a little bit about us?
Yeah, good morning. It's a nice, cold Sonoran morning here in the Sonoran Desert. Happy to welcome everybody. Worldview is a stratospheric company, stratospheric balloon company that does remote sensing and Earth observation from the stratosphere. We do that with our Stratollite, which we get to launch with the live feed here today. With the Stratollite, we're able to produce very high quality imagery with persistence in the stratosphere. And so when you think about Worldview, you would think about us as a company that augments satellite imagery or drone imagery, really creating a high quality product for customers who need imagery of the Earth.
Excellent, excellent. So for this flight in particular, what gets you excited about this flight?
Well, what's cool about this flight is it's the last launch of the decade. Here we are, December 2019, our last launch of the decade, and what's really neat about this flight is it's dedicated to inspiring, creating, and exploring new perspectives for a radically improved future, which is our purpose as a company. And so as we enter this new decade, what's cool is this flight being dedicated to inspiring, creating, exploring new perspectives, it really sets off 2020 because that's when we introduce Worldview to the world. This is when we introduce what we're doing from remote sensing and Earth observation to the world. So enjoy the launch. Thanks for doing this, Matteo. It's going to be a fun day, and welcome everybody, and thanks for joining us.
Oh, well, thank you so much. Hey, so what we're seeing right now is that we're seeing the balloon fill. This is the initial fill of the bubble. This is one of the stages, the early stages of the fill. You see the tube going into the balloon, and that's where we're filling it up with some helium. This is a small portion of the balloon as we're controlling the size of the balloon of this initial fill. You can see right on top there's what we refer to as a crown valve. That valve allows us to control how much helium is in the balloon throughout the whole mission. So this is one of the more exciting times of the process. So so here we go, and here is, I want to introduce you to John Strauss. Dr. John Strauss, how are you doing?
Good.
So John has been with Worldview from the very beginning. You've been on many launches.
Many.
And so we're going to walk through this launch, talk a little bit of the technical, geek out a little bit on both the process for the launch and as well as the vehicle itself. So how about you tell us a little bit about what's going on this first stage here?
Okay, I wasn't sure if you guys are watching, were able to see the start of the launch, but we ended up starting to flow helium into the bubble of the balloon. There you go now. We have very good winds today. They're very light, as they need to be. And you can see in this photo, Jonica is actually holding a diffuser and flowing helium from our helium trailer into the top of the balloon. Mm-hmm. The balloon is actually like 180 feet long, and so in order to be able to fill a balloon like this, you have to kind of control the top of the balloon. Okay. And so we have the top of the balloon kind of looped over a spool, and that's what you see in this video.
So can you talk a little bit about the spool? What does that do for us exactly?
Yeah, the spool basically, for the purpose of fill, divides the balloon into two sections, the filled section and the unfilled section. And so the fill tube that you see that's bouncing up and down is putting helium into the bubble, and the bubble is wrapped around the spool there, and it's basically holding the bubble down.
Okay, okay. And so how much helium are we going to use for this flight?
The whole system weighs about 2,000 pounds, and so we're going to be putting in, I'm going to mix units here, about 150, roughly 150 kilograms total of helium.
Okay, excellent. Yeah. And so this is the process where we're doing this initial fill. As you mentioned, the winds are great. This is actually a beautiful morning to do a launch. You can see the aerostat there, that yellow balloon. So how about we talk a little bit about what the purpose of the aerostat is?
Right, we have two different systems on site to be able to measure winds. Underneath the aerostat, we have an anemometer. It's like a vane anemometer, and it's hanging underneath the aerostat, and it simply rotates with the wind and figures out how fast the wind speed is going. And that's set up at about 400 feet. So we know what the winds are at the top of the balloon when we actually stand the balloon. But we also have a LiDAR system that tells us how fast the wind is going at probably like 10 or 15 different levels between ground surface and 400 feet.
Okay, so because when the balloon stands up, it'll be about 400 feet tall.
That's right.
And so to put in context, that's approximately like a 24-story building, 25-story building.
That's right, yeah.
So why is it so important? Why are the winds so important?
Well, when we start the fill, as you just observed, that's when there's the least amount of helium in the bubble, and the bubble is the most susceptible to gusts. And so we could, a gust early on in the fill could take the bubble and kind of turn it into a spinnaker, and it could wrap around the spool in a not nice way.
Okay, yeah. So you don't want to stress the system
That's
as
right.
as we're filling up.
That's right.
So there, as we're filling it up, we get to a certain point where we will basically release the spool, and then the whole system stands up.
Yeah, right now, as you can tell, the bubble is getting fatter and fatter because we continue to put more helium in it. And so the spool is going to have to actually move, and you'll actually see this forklift that the spool is attached to start moving in this picture to the left towards the payload, and that will allow the bubble to grow as we continue to fill the balloon.
Yeah, so this is a very exciting part of the fill process. We had a little shot a little bit earlier of the Mission Control Center here at Worldview. So that's, there you go. So here are the people who are controlling, monitoring the system right now. There's actually another flight going on. You can see up in the corner, 41 days, 21 hours, 49 minutes. We have another system in flight right now. We're approaching 42 days on that flight. So that's really exciting because that's another long duration flight. This one is also going to be a long duration flight, well over 30 days. So let's talk a little bit about how we fly. How is it that we control the system? So our operating altitudes are what?
This is an altitude control balloon. So we have the ability to change altitudes, and our altitude range is roughly 50 to 75,000 feet. And the way we accomplish that is we have a ballast balloon. We fill that ballast balloon with air. That ballast balloon is fluidically disconnected from the lift balloon, which has got the helium in it, which is what's being filled now. And so we are basically putting in, of that 150 that I mentioned earlier, we're putting in about 130 kilograms of helium just to keep the balloon at neutral buoyancy. So in other words, if you took this balloon, filled it with 130 kilograms roughly of helium, you could put it at any altitude and it will just stay there. It won't go up or it won't go down. This is assuming that we don't have any heating effects. But then what we do is we add a little bit more helium so that we could go up, and that's what we refer to as free lift, lift helium. And then in order to counterbalance that free lift, we add air to the superpressure balloon.
So that ballast balloon is actually effectively adds mass to the system.
It's a variable mass system.
Variable mass system. So in lots of ways, it's a lot like a submarine, right? A submarine has the ballast tanks where you add water to the tanks. It decreases the overall buoyancy, goes down, comes back up. So in lots of ways, this looks like it operates in a very similar way to how a submarine works.
Right. When I'm explaining this to other people, I'll let them know that filling a balloon with air doesn't actually make it heavier until you start pressurizing the balloon. So it'll reach the superpressure balloon will reach full volume, but until it starts pressurizes, it's not going to have any effect on the mass of the balloon.
And that's why we call it superpressure, because the pressure is above the ambient pressure.
That's right.
Above ambient pressure. So but let's talk about why is it important? Why is it important to be able to change altitude, move up and down?
Well, that gives us our ability to steer.
How's that happen? How's going up and down change your ability to
Yeah,
steer?
right. We don't have a propeller on this system, and if we didn't do this, we would just blow with the wind. And actually, we still blow with the wind, but we have to find winds that go in the direction that we want. And so the stratosphere is which is where we fly. We fly in the lower stratosphere. It's got different layers, and we have different wind speeds and different directions. And we will, if we want to go from point A to point B, we might have to go to different altitudes and make different altitude changes to make that trajectory.
Yeah. So what we've discovered, what is true within the stratosphere is that as you move up in that stratosphere, you find winds going off in different directions. By changing altitude, you get to choose the wind in the direction you want to go into. Right. So that gives us a lot of navigation and control.
Right. And more often than not, we're not going to find a layer that's going in the direction that we want, and so we'll have to find the combination of right altitudes to be able to accomplish what we want.
Right, and that's the main function of the mission control.
Yes.
is to control the vehicle, be able to go up and down, and find the winds that get us to the direction that we want to go into. So we had a shot of the spool. We saw a little bit of red around it. So let's talk about what is that red? What is that?
The red is just a protective cover.
Okay.
The balloons are made here, and the balloon
here at the headquarters
yes,
in Tucson.
Yeah, that's right. It's made out of plastic that you might find in a sandwich bag. Obviously, we have special quality control on it. But when they make the balloon, the final thing they do is they package it up into this red, thicker material that is kept on the balloon as long as possible to keep it safe. And there's actually a person, you can see their legs, but you can't see the head. He's standing on a platform right behind the spool there. And as the spool vehicle moves, he's tearing off the protective cover.
Okay. And it's really important for everyone to understand that as we build these balloons, that these are large balloons. We cannot fill them up, and so before the actual launch. So we spend a lot of effort monitoring quality control in order to you can actually see it moving right now.
Right.
To monitor the quality of the balloons. But ultimately, this is the ultimate test. This is where we get to see it that the balloons are properly built. And when we stand up, there will be a full inspection. We're inspecting the whole system as we go.
Yes.
So we did have a shot a little bit earlier of the actual vehicle itself, and that vehicle is kind of the business end of the system. So let's talk about the whole system from top to bottom. So we mentioned that we're looking right now at the lift balloon.
Yeah, and just so the viewers understand, the lift balloon right there has it ends where the orange protective cover ends.
And then below the lift balloon is what?
Is the super pressure balloon.
Okay, so that's our ballast balloon.
That's our ballast balloon.
And then the lift balloon is carrying all the weight that's below it.
That's right.
As well as then the ballast balloon carries all the weight that's below it. So below the ballast balloon is what?
Below the ballast balloon is, there's an electronic system called a rotator. Below the ballast balloon, we have a ladder. It's about 70 feet long. And in that ladder, or on that ladder, we have solar panels connected to it. We have a fill tube that takes the compressed air from the stratocraft, which you could see there, all the way to the super pressure balloon. And we have our parachute system, all packaged in that ladder. Yeah,
so the solar arrays actually, let's talk a little bit about how we power the system. So the system is powered through solar cells.
Right.
Obviously that works great during the day, not so great at night. So we also have a battery system on board that'll carries us through the night. Approximately how much power do we generate?
I believe we came up with something like 3 kilowatts.
Yeah, 3 kilowatts. So to put it in context, if you look at it on average for a house, that's about 3 houses worth of power that we generate. And you can see the solar arrays right there above the heads of the people there. And then we have the craft, right? The actual craft.
That's right.
you can actually see on that craft the camera system that we'll be flying on this particular mission.
On the right side.
Right
of the
on the right
screen.
side.
Yeah.
So the craft is as we mentioned is the business end of the vehicle. So let's talk a little bit about the subsystems that are on this craft. So we have the avionics, right?
Right.
That's where all the computers are.
Right. There's power avionics to take the energy from the solar panels and convert it to something that can be put into the battery.
Mm-hmm.
We have a battery, a fairly large battery.
Lithium-ion battery.
Yeah.
Yep.
To be able to power the compressor, that's what uses the most power, and then a suite of communication hardware and electronics to be able to communicate. We have 2 different SATCOM systems, Iridium and Inmarsat,
Mm-hmm.
and we also have direct line of sight communication as well.
That's right. In fact, so there actually is a what we refer to as a chase truck, a chase team, that for periods of the mission we're actually able to connect up with directly to the vehicle.
Right.
And when we're not in line of sight, as you mentioned, we use these satellite communication systems.
Right.
So we're able to control all the vehicles here in Tucson at our mission control center, and that is mostly done through SATCOMs.
Right.
So, we can operate around the whole world with the SATCOMs. So we are as we're filling, we're still. Oh, look at that! The balloon's getting bigger.
I just heard on the radio that they're 130 of 140 kilograms, so they're getting very
pretty
close to be complete with
So
this fill.
let's give everyone a little bit of a preview of what's going to happen. So we mentioned that as we get to the fill point, we're going to stand up the system. In order to stand up the system, you mentioned we release a spool. So what happens when we stand up the system? What does that look like?
All right. Well, the spool is on a hinge, and there's a latch on the other side. And if it's not clear, the spool is basically a cylinder. If you could tell from the image, there you go. So the side that's closest to you in that video is the hinge, and on the other side is a latch. And you can see that the balloon is trying to lift up wants to lift up the spool, but it can't because it's latched shut.
Mm-hmm.
So when it's time to actually do the stand of the balloon, they'll, engage that or disengage that latch, and then the balloon will just push the spool out of the way, and you'll see the entire balloon stand up and stand right over the stratocraft.
Okay, and that's a very dynamic time of the launch where it all just settles out over the craft itself.
That's right.
Yeah.
That's right. The craft is, we didn't mention this, but the craft is sitting on top of what we call the launch plate,
Mm-hmm.
and the launch plate is designed to hold the whole system down. So the stratocraft is anchored to the launch plate,
Right.
and so when the balloon is standing over the stratocraft, it's not going to go anywhere until we make that release.
So the launch plate basically fundamentally just makes the system heavier,
Yes.
and the balloon can't overcome it until we separate it from the launch plate.
That's right.
And then it can lift the remaining mass. So when we do that, we can talk a little bit about in the image right here. You see this little element there that has red and a little bit of blue. That's the collar.
Yes.
Right. So the collar itself will be a little bit more obvious when we stand up, but that's an important element of the overall system. So let's talk about the collar. Where's the purpose of a collar?
The purpose of the collar is to basically keep the helium in the bubble during the stand. If we didn't have the collar on, you can imagine, or you can see there in that image that I believe that there is about 26. I'm going to say more than that. No, 26 meters from the top of the balloon all the way down to the spool, and then the rest of the balloon is still uninflated and in that protective collar. And if we didn't have protective cover, and if we didn't have that collar on, when the balloon stands up, the wind would try and make the balloon spread out, and that puts unnecessary force and stress on the material. So we keep it on until it's standing, and then once the balloon is standing, it's also good to have the collar on so that it doesn't spinnaker out and lean over excessively.
Yeah. So fundamentally, the collar helps maintain the shape of the balloon of the
Yes,
bubble
yeah.
until we're ready to launch.
Yes.
And then when the shape of this, we'll see a little bit later, is a very tall, skinny shape. What does it look like? Oh, actually, you can see
Yeah.
right now they're finished off on the fill process, and they're tying off. So what do they? How do they close off that system?
Yeah, so they once they finish fill, they simply cut off the fill tube from the diffuser. They tie a knot in it, and then they take a heat sealer and they seal the bottom.
Yeah, you can see them doing right now.
Yeah,
They're
yeah.
in the process of sealing.
So
that,
once they're
filter.
done with, so while this is going on, the remainder of the crew, there's basically a launch crew and a flight train crew, and the flight train crew is responsible for the stratocraft and the ladder, and the launch crew is responsible for filling and for launch and getting everything set up in that sense. So while they're doing the tying up of that balloon, the flight train crew is making sure that subsystems are working properly, that it looks good. We didn't mention this, but right now there's approximately 2,000 pounds of tension, 2,000 pounds of lift that that balloon is creating, and because it's wrapped around that spool, that tension is going through the balloon, and it's all the way up to the it goes to the stratocraft, which is why we actually have that other forklift there in the to the left of your screen. That's taking that 2,000 pounds of force.
Just hold everything in place as it goes through the dynamic stand up.
And that'll move out of the way once the balloon stands.
So as we stand up, as we mentioned a little bit earlier, that gives us a chance to inspect the overall balloon system. What viewers may not know is that right behind us actually is Tucson Airport. So let's talk a little bit about how we interact with the control tower.
That's right.
So how's that? So the control tower is fully aware. I mean, we coordinate with them ahead of time that we're about to do a launch. In fact, they control the airspace, our airspace, just like we control all the other airplanes.
That's right. The balloon, or the whole system, has a transponder on it, so the aircraft can. So we are in constant communication with all flight centers. But for the immediate launch, we coordinate everything. We have to get tower's approval before we can stand the balloon and before we launch.
That's right. So we're clear just like any other air vehicle. So
Right.
sometimes we sit there like if you're on an airplane. Sometimes you sit on the tarmac for a few minutes before you get to take off. Same for us is that sometimes when we stand up, we wait to get clearance from the tower in order to do the launch.
Right. And since we're on this topic, the bubble is much more resistant to winds while it's on the spool, like you're seeing here. So if there seems like there's going to be any kind of delay, then we're going to hold on the spool, and we won't stand the balloon until we actually are relatively confident that we're going to get quick clearance from the tower.
Okay, and so these kind of systems. So this is a very heavy lift. So we're obviously launching a relatively large balloon. So these kind of systems actually have been done by NASA and other entities. Maybe not as much as we do in terms of controlling it and in terms of altitude control, but there's a long history of stratospheric ballooning, right?
Yes.
So NASA's done quite a bit.
Oh yes, yeah. In fact, our chief launch director is from NASA. Came from NASA.
That's
now
right.
Works for us, and he's been working for us for almost as long as I have.
Okay.
Let me cut in here and let
yeah.
you know that on the radio, they're doing the clearance to stand poll right now. They're going through each subsystem, and they just did weather and safety.
And we are all go so far?
We are go.
Excellent.
We're
Excellent.
going to get mission control.
Okay. So things are progressing. That's fantastic. Like we said, today is actually a beautiful day. It's the winds are nice and calm, so it's a great day for a launch. And in Tucson, it's always it's a beautiful sunny day in the morning. So Tucson itself is actually a great place to do launches.
It is, and you wouldn't normally think that, but we have discovered, this time of the day, there is with the right conditions, this time of the day is perfect.
So we have a full-time meteorologist on the company, Jake.
Yes.
And let's talk a little bit about his responsibilities.
Okay. He, for launch, he starts looking at forecasts like a week out because that's when the winds forecasts start to be reliable. And I want to stop here because we just got approval from Mission Control. They got approval from the tower. So at any point now, they're going to stay on the balloon.
Okay. So we definitely don't want to miss that.
Yeah.
As we mentioned, our meteorologist he looks at the weather conditions as we approach the flight. Not only just the weather conditions in terms of ground winds, but also trajectories.
That's right.
For this mission as to which direction it's going to go. Very much we choose a day that is where things line up, both in terms of the ground winds having good launch conditions, as well as getting great trajectories for the mission itself. I looked at removing the last of the protective cover.
Okay, good.
So it looks like we're getting very close to standing up. So let's talk a little bit about one of the other things we're working on is working on our next spaceport, what we refer to as Spaceport 2. That's in Australia. You just came back from Australia?
I did.
So you see any kangaroos?
I'm sorry. They're about to do the count now for the stand.
Oh, okay. We're definitely don't want to miss this. So we're gonna count down for the stand up.
They're doing the countdown now.
Okay.
3,
Let's just
and
watch. This is a very exciting part. Oh, there it goes. So you can see the collar holding the shape of the bubble as it stands up.
Yeah, and they called clear, which means that the balloon cleared the spool safely without being damaged by the spool.
Yeah, this is a great launch. Great stand up.
And you guys you may be able to see on the video, oh no, you won't be able to, but there is a line that goes all the way from the collar down to the ground. It's a manually controlled collar. We have a remotely controlled collar, but it's for a larger balloon. We're still working on that for the smaller balloon.
So now that we're stood up, that basically means we're ready to launch, right? So we just have to work on the final clearances to launch. So we'll probably be launching relatively soon now, waiting for the tower. What
we've done now is they just got the clearance to go under the balloon. There's a mandatory hold, so everyone is now running underneath the balloon to getting the ramp out of the way, getting the air conditioning and the ground power out of the way if it's still there.
Okay, you see them working on it right now?
That's what they're doing
Doing some inspections?
They're doing inspections of the fill tube. We mentioned earlier that the compressor for the super pressure balloon is actually in the Stratocraft, and there's a fill tube that goes all the way up, and they want to make sure that's looking good. We want to make sure that the lines, the rigging for the parachute's still good. And so that's what they're doing now. You can see part of the ramp being rolled off to the left there.
Yep.
The forklift there is what we call the fill restraint forklift. That was taking the 2,000 pounds of load. They're going to disconnect that and move it out of the way.
Yeah, so we, as we're inspecting, do the final checks before the launch. So for anyone who's actually watched a rocket launch, there are differences between what we do and what the rocket does. In particular, what I would say is that it's great to watch a rocket launch. There's like the fire and fury of a rocket. There is no fire and fury here, right?
No.
It's all grace and beauty. It's and hopefully we'll get to see that that will be communicated over the screen. Because when these things launch and the system just floats away, it's a very graceful takeoff, and it's as moving as a rocket, but in quite different set of emotions.
I don't know if you just saw that, but they actually turned on the compressor.
Okay.
So they're starting to fill the super pressure balloon with air now.
Yeah, so it's a little bit hard to that there's a part of the balloon system that looks like a just extra thick line.
Yeah.
That's actually the super pressure balloon. It's uninflated right now.
Right.
So as we launch, it will. I'm sorry. As we go up to the what we refer to as anchor, which is where we hit a neutral buoyancy. That balloon will be full. So you can see right there. That is the ballast balloon.
Yeah, the super pressure balloon.
Super pressure balloon, and in its compressed state, and that will be filled up.
Right. It's about 130 feet long, as it is now. Once it's fully inflated, I came up with a great description. I'm sure all the viewers will know exactly what I'm talking about. It looks like a 2P orbital.
Okay, for the chemists out there,
Yeah.
they'll know what a 2p orbital is.
Or
Chemists and the
how about
physicists.
two jelly beans stuck together?
That's, maybe more people don't know what that means.
Yeah. Once it's fully inflated, that's what it looks like.
There's a nice picture of the lift balloon. It's gently rotating in the breeze there, and we're continuing to do inspections. We're probably coming close to the end of the inspections. I'll tell you, this is just a little silly, but as it takes off, I don't know if you've ever been to the Monterey Bay Aquarium. They have great jellyfish exhibits. There's a lot of beauty in this that looks like the jellyfish exhibits. At least that's what comes to my mind.
Yes, yeah.
We're still probably finalizing the overall inspections, waiting for the tower. When we release the collar, right, and you'll see the shape of the balloon change a little bit when that pinch point gets released. That's when we are ready to go.
That's right. As soon as the collar hits the ground, they'll take the safeties off the Stratocraft feet and then let it go. I heard over the radio that everyone on the ground side here is clear for launch, but mission control is still not ready.
Okay.
It seems like they're perhaps doing additional checks.
Yeah, so we're constantly checking to make sure that we're in communication with the overall system, with the craft, the avionics, the over the horizon SATCOM system. We have our chase truck. We're checking out the systems to make sure we're communicating with the chase truck. So we have a pretty well experienced team. Like we mentioned a little bit earlier, the team's not only getting ready for this launch, but they're also monitoring the system that's in flight. We're getting pretty ready for launch. It looks like we're backing away a little bit. That's all. The funny thing is that I've always tell people, when you see people walk backwards, that's when we're ready to launch.
I still haven't heard yet from Mission Control if they've even reached out to the tower for approval.
Okay, so we'll wait for that. So let's talk a little bit about a few of the people that are on the line. So we have. So you mentioned our launch director.
Oh yeah,
Frank.
yeah. So we have. There's basically 4 different teams working right now. The launch crew,
Mm-hmm.
the flight train crew, a chase crew,
Mm-hmm.
and then our mission control crew. And so the chief launch director for the company is Frank Candelaria. We talked about him earlier, and he used to work for NASA, now works for us, and he's actually training Les Herrick.
Mm-hmm.
Les Herrick is the launch director for this flight.
Okay.
And then the rest of the launch crew is Raul Robles, Eli Todd, Jonica Johnson, Bettina Sanders, and Izzy Severos.
Okay.
So that's the launch crew. The flight train crew, who worked on setting up the Stratocraft and the valves and the ladder, is Danny Robinson, Tony Bleak, AJ, Adalbert, Josh Hoyle, Kyler Felton, Dan Enslin, and Brett.
Yeah, so this is quite an experienced team that we have
It
here. It's true that it's the whole team within Worldview that works on every element of this. All of us have to get our job right in order to make these things successful. It's a great crew. It's a great team.
It is.
So we can talk a little bit about the mission control.
Okay. We have Justin Piner. He's our lead flight director. He's relatively new with the company, but he's come on board and picked up everything really quickly. Olivia Brinkerhoff is our co-pilot. Nastia Ford is our flight coordinator. And then we have Sebastian Padilla. He's one of the original engineers that started Worldview. He's been training. He was our entire mission control for the longest time, and he's doing the training now.
Yeah.
And
Sebastian is our chief engineer here at Worldview.
yes, that's right. And then we have Jake Gannon, who's our meteorologist.
Yeah,
we
Jake.
mentioned.
We all rely on Jake. Jake
Yeah.
is at these stages like the most important guy. What he says goes. You actually can see. I'm sorry, real quick. If you look at the images right now, you can see the ballast balloon start to fill a tiny bit.
Right.
It's as John mentioned, it's a 2-chamber system. So there's a top chamber and a lower chamber that are connected to each other. So
Not quite the 2P orbital yet.
not quite the 2P
Yeah,
orbital yet.
yeah.
Yes, so for those chemists out there. And then the chase team.
Yeah, we got Carlos Lopez, Jerry Tan, and Glenn Patterson. They're in a vehicle. They have the ability to communicate with our balloon, and they're going to go downstream and meet up with the balloon at a later point, so that they can start collecting some of the video data.
Okay, excellent. So this is this is a great image. I tell you, every flight I've watched, every launch I've been able to witness, it's always exciting. It's as you mentioned, it seems to always happen early in the morning because that's when the wind conditions are good. And in the summer here in Tucson, early morning is not so bad. In winter, it's a little bit more chilly.
Yes, yes. I'm thankful that they actually got a heater under this table.
Absolutely. So. So as we're progressing, more likely than not, we're waiting for clearance from the tower. Looks like all systems are go, and we'll see. But the wind conditions are fantastic. So the company, when we started, is really started with a very special event or a special project.
Yes, yes.
That was referred to as Stratix. That's the Stratix. So, and you were part of Stratix.
Yes.
So, what was that all about?
So at the company I worked at before, we ended up getting a project, and we named it Stratix. And the project was to lift a person underneath a high altitude stratospheric balloon.
Not just any person.
Not just any person. His name is Alan Eustace. At the time, he was a vice president of Google.
Okay.
And he came to us while there was another project going on by Red Bull, and the daredevil in that project was Felix Baumgartner. So they ended up doing a space dive underneath a balloon. From underneath a balloon, they went to about 125 or 126,000 feet back in 2012. Around that time is when Alan Eustace came to us, and he wanted to basically accomplish the same thing, not to break the record, but just to do it, because he has this desire to do that kind of stuff. So that's where our experience came from, and the engineers who worked on that were the engineers who came over to start Worldview.
Okay, so but to be clear, he broke the record.
Yes, yeah, Alan jumped in 2014 in October. I think it was the 22nd, and he made it to about 136,000 feet. Just around 136,000.
Yeah. So I have to say that Worldview has a fantastic origin story. The fact that we were able to set the world record for diving from the stratosphere. Not only was there a balloon system in order to bring Alan up to that altitude, but there's not enough oxygen for him to breathe up there, right?
Yes.
So we actually had to design a spacesuit for him too.
That's right. That's right.
So one of our engineers here, Ryan Lee, led that effort to build him his spacesuit.
That's right.
Ryan came over from NASA, designing spacesuits for NASA.
Yes.
And so Ryan is still here, so we're super lucky to have him here. But yeah, so Alan was able to break the record.
Yes, back in October 2014, and then in December, even though Worldview was already started as as a business, the people moved over, or the engineers moved over, like in December of that year.
Okay. So we're still waiting for, I guess, to get clearance from the tower.
Well, there is a technical issue that they're working on.
Okay.
So.
Okay. So maybe this would be a good time to go on hold.
Sure.
While we wait for all the systems to be checked out.
That sounds good.
Okay.
right now.
Okay, hey, welcome back. We got clearance from the tower. We're going to be ready to go at any moment. So we're the final checkouts were all successful. We're ready for a launch. We're on go. So what you'll see shortly is since we have the go from the tower, the collar will be released.
Yes.
And once it's released, it's going to happen very quickly. We're just going to go, and we'll watch the system gracefully move. So as we talked about a little bit earlier, that the collar is near the bottom of that bubble that creates the shape right there. That's the collar itself. And when we're ready to go, probably a little bit on the winds being just right and so on, but we did get the clearance from the tower. You can see the winds a little bit kicked up a little bit. The system's leaning. That's not an issue whenever we're ready to go. So the system fully checked out. The control, mission control, was able to talk to all systems. All systems are now ready. You can see this guy's on the mission control, very casually waiting for things to happen.
Okay, the compressor's back on, and they're about to pull the collar.
Okay, so we're going to watch for the collar to be released.
And as soon as the collar, there's a couple of parts that come down.
Yeah, you see a little bit of fluttering of,
Yep.
of pieces falling to the ground.
Yep.
Very typical when the collar gets released. There it
There it
goes.
goes.
So now the balloon takes on a slightly fuller shape. You still see the helium more or less captured near the top in a bubble. You can see the Ballast Balloon, the super pressure balloon below it, and its two lobe slightly filled out. Oh, there you go. Great shot of from above as the collar lands to the ground, safe and sound. So that means that we're going to be ready to separate and launch.
Yeah, you could see right now that, well, not from the TV, but if you're looking at it from the side, there's a pretty serious gust that's taking, creating too much of a catenary. So we're going to wait for that gust to go by, and then
wait
we'll
for it to just calm down a tad bit, and then we're ready to go. So this is yeah, you can see it leaning. So as we said a little bit earlier, when these things launch, they just very gracefully separate from the ground. Hopefully we'll get some video of it moving away from the ground. I'm going to wait a tad bit for the winds to die down a bit. So as we mentioned, our meteorologist is constantly monitoring the wind conditions. We were measuring the winds all the way from the ground up to the top, at 400 feet or so. That's done with the hydrostat and with the LiDAR.
Yeah.
The interesting thing about the LiDAR is it's a laser system. It measures the particles in the air, and
That's
it
right.
measures the velocity of the particles in the air. So it gets to determine the speed of the winds by that method. Great view of the craft right there. Great view of the balloon system with headquarters for Worldview behind it.
Yeah, they've turned off the compressor so they don't grow the super pressure balloon too much.
Okay.
Because that's making it lean more than it needs to.
And at this point, it's a little bit of a waiting game, just waiting for things to die down a bit before we're ready to go.
Everyone should be familiar that gusts are cyclical, so when this one goes away, that's definitely a lean that we don't want to release on.
Yeah. So part of the process that we do in terms of getting ready for a launch is that we're measuring the winds for days and weeks on end prior to the launch, so we know the cyclical nature of the winds here on Spaceport Tucson. So we talk a little bit while we're waiting on the construction of the balloon. You can see the balloon itself is made of panels, right? Technically, those are called gores. Gores. So in some ways, if you think about a beach volleyball, right there, you see these panels on a beach volleyball. They're all sealed together. That's how these are manufactured.
I think there's something like 100 panels on this
on the lift balloon. So we should talk a little bit about how does the lift balloon structurally support all the mass below it.
Well, the panels basically are there just to hold the gas in place. But between the panels, you'll see these stripes, and we refer to that as load tape, and that's made out of balloon material, but also has woven in it some high strength fiber. And so the lift of the helium gas is actually transferred to these load tapes, and that load tape is what is taking all the load.
Yeah, so all the structural support that the lift balloon provides to that's required in order to lift what we call the hook-on mass below it is all carried through these load tapes. And the load tapes is what we produce here. You can't go out and buy load tapes.
That's right.
So it's something we produce here at Worldview as part of our construction of the balloons. Similarly, the ballast balloon has to carry the weight below it. It has to transfer all that load from below it, and so it also has a similar system, not tape, right? But tendons.
Right, but those also take up since it's a super pressure balloon, there's a lot more hoop stress in the balloon, and so the tendons in the super pressure balloon are actually considerably stronger to manage that pressure.
Yeah, so you mentioned hoop stress. So hoop stress is the circumference of the balloon, and so it's not only the stress by the weights below it, but also the stress circumferentially.
Right, that's right. It's the force that wants to split the balloon in half, so to speak.
Right. So these are highly engineered products, right? There's a lot of engineering that goes into it,
and testing
that goes into it. So just an interesting thing, before coming to Worldview, I never thought of how much high tech goes into these systems. I often like to tell people that I didn't realize balloon systems required so much software. There's actually quite a bit of technology, not only in the engineering and design of the balloons, but the craft itself. There's computer systems, obviously, to support payloads, carry different types of payloads. This one happens to have a camera system on it. We are working on the next generation as well, and the next generation basically allows us to support more different types of payloads. We increase our overall ability in terms of how much weight and mass and power that for a payload that we can carry. So we do a lot of trajectory and analysis, right, for these flights, right? There's a lot of safety efforts to go into it to make sure. Are we getting close to launching now?
Yeah, they're doing it right now.
Okay, he's going to pull on the cord, and that's going to release the vehicle.
There you go.
And there it goes,
nice,
and we're off.
Liftoff.
Yay! Absolutely. Look at that. So we have liftoff. So as I mentioned before, the system gracefully goes up in the air. It's actually it's always very magical. It's a very magical thing to watch. The system float away, and as it goes up, hopefully we'll be able to see some images from the system itself. It takes a couple hours in order to get to anchor point.
Yeah, it ascends, I think, somewhere between 800 and 1,000 feet per minute, but we don't have the normal full lift, free lift that we want to keep in there, so it goes a little bit slower than the 1,000 that I mentioned.
What a great view! You get to see it float away as we get to as the winds and all these winds and all the trajectories that we're following will just basically is things that we model and we predict, so we know exactly where we're going. Let's just watch this. Watch the system with the Sonoran Desert background.
This is a view we normally don't get.
Yeah, this is a view we normally don't get. So this is So with that, I think John and I, we're gonna be done. We'll continue with video a little bit more. I want to thank everybody. I want to thank you, John.
Thank you, Matteo.
For being here with me and going through being able to show and share this with the people that are our viewers. We will have updates, so you please follow us on Twitter at Worldview Space. We are super thankful for you guys joining us, and we hope to see you again. Thanks, everybody.